Hey class, Mr. Moyedin here to show you some terminology regarding angles that we'll be using in our proof and logic lessons. So let's take a look. Here we have three lines. Notice that the green and the blue are not parallel. They might be in some cases, but not in this case. And the red line is the one I want to focus on for the moment, and that's what's called a transversal. Transversal. So it comes from the idea of transversing or traversing or to go across, like to transit, to travel. The red line goes across both the green and the blue. In short, a transversal is a line that crosses two or more other lines. And in so doing, it creates a lot of interesting relationships. So you'll notice there are 8 angles, at least, in this picture. So I'm going to number them to make it easier to refer to. Angle 1, angle 2, angle 3, 4, 5, 6, 7, and 8. So in class, at the end of last week, after our assessment, we talked about vertical angles. And in fact, we've already seen vertical angles, but vertical angles are angles, in short, that are directly across from each other. So angles 2 and 3 are vertical. Angles 1 and 4 are vertical. Angles 5 and 8 and 6 and 7 are also vertical. Angles 5 and 6 are not vertical. They're supplementary, or in linear pair, or adjacent. There's some more terminology we have to use in order to better describe the more complex images that we see. So our terminology here is going to describe sets of angles. So in this figure, there are many possible sets. The first one I want us to focus on is the idea of corresponding angles. Corresponding. Well, to correspond means basically to match, right? For example, if you're sitting in a certain position at your table in my classroom, then someone who's sitting in the same position at another table is corresponding to you, right? So angles that are corresponding are paired like this. Angle 1 is corresponding with angle, sorry for this bad pen, angle 1 and angle, let's take a look. Angle 1's position is in the same position as angle 5, right? They're both in the sort of the top left corner of each of these individual sets. You got 4 here and 4 there. So angles 1 and 5 are corresponding angles. Well, what's the corresponding angle for angle, let's say, 4? Well, let's take a look. Angle 4 is here. Well, what's corresponding to it? Well, you'll see that angle 8 is its corresponding buddy. So 4 and 8 are corresponding. Now notice that I'm not saying they're the same. They might be the same, but in fact these lines are not parallel, so we can't say that they are the same. We'll prove some of these relationships in class. But corresponding means in matching positions. Corresponding means in matching positions. Some other phrases you'll see. Alternate interior. Quite a common phrase in geometry. You may have even heard it before. Alternate interior angles. Well, if we just use a bit of common sense, interior would be the inside of these two lines. So when I'm talking about the interior, we're referring to this region right here. This region. That's the interior of the two lines, right? So we're going to be dealing with this set right there, the interior set. So let's take a look. Alternate interior, well, for example, angle 3 is in the interior, so what is alternating with it? Well, it would be on the exact opposite side, so that would be angle 6. So angle 3 and angle 6 in this diagram are alternate interior, and frankly, angle 4's alternate interior angle would be angle 5. Alternate means kind of like to alternate, to switch, and interior on the inside of these two lines, alternate interior. Well, by the same token, you can imagine a discussion about alternate exterior. Alternate exterior angles, well, where's the exterior? Once again, common sense, outside of these two lines. So this area over here and this area over there, that's the exterior of this region. So we're dealing with those 4, with these 2 and these 2. So what's on the exact alternate side of angle 1? Well, angle 1's alternate exterior buddy would be angle 8. Again, in this diagram. Angle 1 and 8 are alternating, and they're in the exterior. And likewise, angle 2's alternate exterior would be angle 7. alternate exterior. And the final pair we'll look at is something called same side interior. Same side interior. Well, once again, we're talking about the interior, so we're talking about this space in here. So we're dealing with that set, this set right here. So of those, for example, angle 3. Well, what's on the same side in the interior as angle 3? Well, 5 is on the same side of the red line, right? So angle 3 and angle 5 are what are called same side interior angles, and likewise angle 4 is on the same side in the interior, in the inside, as angle 6. So corresponding angles in matching positions, alternate interior angles alternating on the inside, alternate exterior angles alternating, again switching, on the outside of the two lines, same side interior inside the lines, but on the same side of the dividing transversal. I'll close here with one other observation. So earlier I said that the green and the blue lines were not parallel in the previous diagrams, but here it looks like they might be, right? Just to the naked eye. It looks like the green line and the blue line might be parallel. Now, in class, you'll see occasionally, starting next week, little figures like this, little labels on lines. And if they have the same number of these little ticks, then that's telling you at a glance that the green and the blue are parallel. But if a pair of lines does not have a mark like that, then you don't know. They might be parallel, we can't say for certain. Again, this is Euclidean geometry, not necessarily coordinate or Cartesian geometry. So we have no way to find the slopes. All it is just a green line and a blue line in empty space. So we're going to be looking at how to prove that lines are parallel without having the benefit of using slope. So in this case, I want you to think about how you can prove these lines are parallel. In other words, think about what angle 5 and angle 1's relationship would need to be if these lines are parallel. And we'll be doing some of that exploration in class. All right, hope this helped.